Okay, I didn't quite understand from the introduction video why you inserted a set screw here. That didn't make sense to me.
Okay, so here is another view, right? There's that set screw being installed. In this particular part, there's kind of like, there's already a flat in the linkage. Oops. Oh, come on. There's already a flat in the linkage right here. And that flat corresponds to, it's kind of hard to see, but there's a flat on the shaft as well. And so because the flat on the shaft mates with the flat in the linkage hole, that shaft won't spin in the linkage, which is what we want. Because what would happen if the shaft did spin in that linkage? Why would that be a problem?
I'm not sure.
Because then the linkage would not move at all, and then the mechanism wouldn't move at all. You just have a shaft that's spinning inside a linkage that stays in place.
Okay. The next question that I had is highlighted here in yellow.
Well, hold on. We didn't really answer that question.
Okay.
This is what I had on hand, so this was the example that I used. But if there wasn't a flat here in the linkage hole, and well, let's just stop there. If there wasn't a flat in the linkage hole, I still need a way to prevent relative motion between the motor shaft and the linkage, because the linkage has to rotate with the motor shaft. Otherwise, this mechanism just doesn't work. And if we had to lock that motor shaft into the linkage so that the linkage rotates with the motor shaft, that's why we use the set screw. So there's here's the set screw right here, and there's a threaded hole in this linkage. So that this linkage right here, that is this part right here. That's what we're looking at, this linkage. And the motor shaft is inside there. It runs through the linkage. And so there's this threaded hole right here that goes all the way into the hole in the linkage where the motor shaft goes through. And as we thread that set screw, as we turn that set screw into the threaded hole, eventually that set screw is going to go far enough down that it hits the shaft, and it bottoms out, it binds on the shaft, and it basically joins, maybe joins isn't quite the right word, but it locks the motor shaft in place relative to the linkage. So now the linkage has to move rotationally with that motor shaft. Does that make sense?
Unfortunately, that doesn't make sense. It's one of the examples that I need to see it, and yeah, that makes sense.
I'm trying to think about how else I could explain this. If we say that, so this is our motor shaft. We're going to look at, we're looking at this view, right? So we're looking straight down right there.
Yeah.
And we're saying this gray circle is our motor shaft. And then let's say that in yellow, that is that's the linkage, and actually, you know, that linkage extends off, something like that. Now, if I were to just hold this yellow linkage in my fingers like this, and there is a little bit of a gap between the outside diameter of the motor shaft and the inside diameter of the linkage hole. If I was just to hold this linkage with my fingers like this, would you be able to spin that shaft, that gray shaft?
Yeah.
Right, you would. And in this application, if the motor starts turning and my motor shaft starts spinning, but this linkage doesn't move with that motor shaft, then I'm not going to get my reciprocating motion. It's kind of hard to turn this without it being plugged in, but anyway, this mechanism is not going to move at all, right? This linkage will just stay where it is and not move at all, and the motor shaft will just spin freely inside. Does that part make sense?
Yeah,
Okay.
I get it now.
You get it now. So just if anyone else listening to this doesn't quite get it yet, when we put a set screw in here, this is what we have in that mechanism we just showed. This is a set screw, and it's, you know, there's a threaded hole where that set screw is turned in. This interface right here, where the set screw bottoms out on the motor shaft, that's what's going to lock the motor shaft rotationally to this linkage. And now the linkage spins, rotates with the motor shaft.
Throughout this lesson, I kept on asking myself, why not just use a regular screw? I can see myself just putting a regular screw in there. And I ask myself, what would be the problem? Because they have the same thread, as you said.
Mm-hmm.
Really, the only difference is that one has a head and one doesn't, correct?
That's right.
So I was thinking, why would I not want to have a head? Well, maybe I don't want it to be seen on the exterior. Maybe if there's a head on the outside, it could affect or it could cause damage to other parts in the surrounding, or be a hazard. You will scratch off your hand, etc. But that's really the only reason. And if screws are cheaper than the set screw, then I would just use a screw.
Yeah, you certainly could do that, and that would work just fine. That's a really good point, a really good question. Really, the only reason is what you said, that there's a screw head on one and not on the other. Set screw doesn't have a screw head. And like in this application, it would be fine if you had a screw head sticking out here. It might, I don't know, this is up to personal interpretation, I guess, but I think it would look a little bit odd if there was this, screw head just kind of hanging out here. Whereas the set screw, we can turn that set screw in so that it's below flush, and it's just a nice clean surface. But there might be applications where the area where your set screw is, maybe that's covered. Maybe that there's something else that kind of goes around. There's some kind of housing, and a normal headed screw wouldn't fit in there. And so for that kind of application, you can actually bury your set screw all the way in your part so that it does not take up any extra space.
Okay. My second question was going to be about right under the photos at the top. I highlighted this in yellow. And marrying the mating part. Could you define marring?
Yeah, marring or to mar. Marring is like abrading or scratching a surface. So if you can, let's go back to that sketch we had. If you can imagine this interface circled in green right here, as you turn that set screw in, it's going to bind down on this shaft, right? The outside diameter of this motor shaft. And just think about a metal set screw just, gouging into another part. What's going to happen there?
It's going to cause friction, wear.
Mm-hmm. Yep. Friction and wear, and it's going to scratch or mar this diameter. Marring is basically scratching or abrading a surface. That's what marring means.
So marring the mating part. The mating part is the rod inside here.
Mm-hmm.
Okay.
Right.
It's a risk that should be taken into consideration.
Yes.
Well, yeah, you're basically putting a screw in there, and on the other side of the screw, you're gonna hit the mating part.
Mm-hmm. Yeah.
Okay, that makes sense.
Yeah. So if one reason people like using, well, actually, before we answer that, let's go back to this question. Are we ready for these?
I'm ready.
Okay. So if a designer did not want to use a set screw to hold a shaft in a hole, what are some other options for fixing the shaft in the hole?
I'm reading again. Did not want to use a set screw to hold the shaft in the hole. What are some other options? Just put a screw.
Okay. Yeah, sure. Okay, you could put a screw in. What else?
Maybe you use one of those, I forgot the term, but it was the little cylinders that you press fit.
Like a spring pin.
A spring pin, but the thing is, it's permanent.
Let's see. So a spring pin, if you had... We had a housing that looks like that. We're just gonna recreate that same sketch, and then we had a shaft or something inside. A spring pin would basically go all the way through both of them, right? You'd have a hole cross drilled through both of these parts, your yellow housing and your gray shaft,
or even not all the way, maybe here to here. And the pin there, and press fit it in. And if you press fit it in all the way, it probably is going to have just a little bit sticking out. Depends on how much force you push down on.
Yeah. You could do that. Typically you don't. Typically you're going to go all the way through because it's going to be a stronger joint and allow less relative motion between the two. But yeah, that's definitely one way to do it, is a spring pin. Another way to do it, when we talked about dowel pins, you remember what one of the things we talked about?
No.
It starts with press.
Press fit?
Press fit, that's right, yeah. So if the diameter of that gray shaft was like, a few 10,000ths of an inch larger than the whole diameter in the yellow part, you could do a press fit in there. But what does a set screw allow you to do in terms of access to that shaft that a press fit does not as easily allow you to do?
Well, anytime we have the set screw, you could unscrew it and take it out.
Right. Yeah.
But once you put this one in, you're pretty much stuck with it.
Exactly. Yeah. Yeah. So if this was like some kind of production application, you might want to do a press fit because you're never going to need to take that out. Maybe you never want it to come out, so a press fit might be great there. But if this is developmental, and you think that there's a chance that you might need to get that shaft out, then a set screw is a great option. Now, what if you have a really tight interface, like a really very small gap between the diameter of your shaft and the inner diameter of your housing hole? Maybe there's only like 1,000th of an inch of total gap in there, or maybe even half a thousandth of an inch of gap there. Maybe you need that really close, like a slit fit for your application to work well, and then you put a set screw in there and you bind down on that set screw and you kind of gouge the material in your shaft. Could it be difficult to remove that shaft in such a situation?
Yeah.
It could, for sure. Yeah, because you have such small clearance around there anyway. And if you put that set screw in, in here, and you really gouge it out, then like if you zoom into this area right here, we're looking at that, maybe that ends up looking, something crazy like that, where material actually got displaced and deformed because your set screw drove in there really hard. And this is obviously not a very nice circle, but pretend the rest of that is a circle. Because this is something that's often done when using a set screw, we're gonna talk about this. What might you be able to do to your shaft to ensure that even if you use a set screw, we're in a tightly controlled diameter situation, you'd still be able to get your shaft out? What might you do to that shaft?
Lubricate it?
You could try lubricating it. Yeah, maybe, but you're still going to have this material that gets displaced and mechanically is like now preventing that shaft from being removed.
So how can we prevent that from happening?
Exactly.
Can you give me a hint?
It's a modification to the shaft itself, a geometry change.
So before I insert the shaft in the hole, I have to do something to it.
Yeah.
Perhaps drill a hole where I think the set screw is gonna go in.
Oh, that's an interesting. Okay, cool. That's totally valid. Yep.
Like this.
Like that, a hole in there, and it would be not a through hole, right? It would have a floor in that hole where the set screw does bottom out.
Yeah.
Sure. Yeah. That kind of gets at the heart of what my answer is going to be. You could certainly do what you were going to do. Something that's really common is you create a flat. So now, instead of, if we were to complete this circle with a dashed line, it would look like that. But by creating a flat here, now you have an area, and this functionally does the same thing as the hole that you were talking about. And maybe I'll ask you why this might be a better solution afterwards. But you have your set screw in here. Now, if you're deforming material, that material deformation, it's still going to be there. Whatever it looks like, something like that, right? But I'm exaggerating here to make my point. That material deformation is still going to be within the confines of that circular profile. So your housing, right? Your housing on the outside. Oh, well, that just messed it up, but is going to look like that. So your deformation is going to still be within the confines of the inner diameter of your housing. Does that make sense?
So just to clarify for all the viewers, how do I turn it back to the red pen? Okay. So when we put the set screw in, deformation is what we call it?
Deformation, yeah.
So it's going to get a little deformations here. That's, I suppose, inevitable, correct?
Yeah.
So it still wouldn't matter because when it rotates in here, this deformation is not going to get stuck on the walls.
That's right.
And that's why it's a good idea to make it flat, as he showed back here.
Yeah. So why would you use a flat as opposed to a hole, like you said?
So the idea that I proposed is to have a hole.
Mm-hmm.
And what Aaron showed, how do I erase that?
Just use this undo thing. Okay.
So what Aaron proposed was to have it like this.
Right.
So this versus this.
Right.
And he's asking me now, why would this be better than the hole?
Right.
My hypothesis is that if we have to put in a set screw, you have to be very precise as to where you put this one. Also, with the leftover, well, that already answers it, but even a step further, you have to really put it exactly where you made the hole. And with this one, you have all this area to choose from, so you could put it there, there, there. It's okay, all those areas.
Awesome. That's exactly right.
Okay.
Yep. Cool. Okay. So that answers B right there. And we've already really
talked
about C. Yeah, so
we're finished.
I think that's it.
All right.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.